there would be a large crowd, thus the 2 floors of dining for today's Startup Cafe. Thanks for everybody who's up at LaValle. Today is a special guest for us, somebody that I had the privilege of meeting when he returned to Champaign-Urbana. So Steve LaValle has been a faculty member on this campus. He also got his PhD in electrical and computer engineering here on this campus, so strong ties to us. But when he left this campus to go on sabbatical, he probably never would have dreamed of how he would come back to return to us and the adventure he would have along the way. That's one of the best entrepreneurial exit stories of recent past. He was called upon by this company with young entrepreneurs involved because they needed technical help, and he's going to tell you about that journey. I think it's important as we, as entrepreneurs or in the entrepreneurial community, think about how to put together a team and what you need to make an effective team. And that you need not just the idea, but also the technical expertise and the business execution. And all of that seemed to come together for Oculus to be a remarkable story. But Steve LaValle is also an expert in virtual reality and now sharing that on campus. He and his wife, Anna, were both instrumental in working on Oculus. They both joined the company, which we'll talk about, and they're both teaching students now in computer science on this campus. So he said his course is way oversubscribed, but if you're a student in the room, hopefully you'll have a chance to explore a little bit more and learn about some of the human-computer interactions that can be advanced with the type of work he does. So please join me in giving a round of welcome to Steve LaValle today.
All right, thank you very much. Can you hear me okay? Do I need a microphone or is this fine? Oh, no video? Oh, then can I get a clip one? Okay. All right, thank you very much for the invitation to come here. It's great to be back. I've been back since July. So some of the background's already been gone over. Laura's told you some things, but give you the timeline of Oculus. The company was founded around July of 2012. So about 2.5 years ago by Palmer Luckey, a teenager from Long Beach, California. It raised a couple of million on Kickstarter, so its value at the time was around a couple million. I joined as a consultant a few days after the Kickstarter closed. Helped with basic math, software, head tracking, things like that. Okay, fine for that. What's that? I don't know. People can hear me the one way or the other. Okay. So let's see. So I joined as a consultant, started working on basic math software, head tracking, which is a very important problem for virtual reality. It was one of the reasons why I had trouble succeeding back in the 90s in terms of mainstream adoption. We shipped a development kit, about 70,000 or so units back at the time. And at that time, I kind of quit my university activities and joined full-time as the head scientist, worked on all kinds of things, got into perceptual psychology, human factors, health and safety, and many, many other things along the way. And the value of the company grew at a pretty incredible pace, so that by less than a year in, it was about 16 million in value. And by Christmas of 2013, it was 275 million. And by March of last year, it was announced that Facebook was acquiring us for $2 billion. So, so it increased about 1,000-fold in value while I was there. Well, after that, it's hard to top that experience. So anyway, I came back here and wanted to pursue new research, new activities, meet new people, and continue as a professor. I wasn't trying to leave the university system, but this incredible thing happened. This is probably not a typical experience. I had no prior industry experience. Or business or entrepreneurial experience. I was just kind of curious, so I figured I'd try it out. And so I'll give you I'll try to talk to you about my perspective along the way, how I got into this and why and what my background was, in case that's helpful to you. But it's not even repeating the same kind of story again. I have no idea how to do that a second time. It's different for everybody. It's different in every circumstance, every market, every product, the people you work with, all kinds of things. But I can at least share with you my experiences. Maybe that might be helpful to you. So I titled my talk, Well, How Did I Get Here? Most of you are probably not old enough to know what this is from, but there was a song that came out around 1980 from Talking Heads, where David Byrne was asking, maybe looking later in life, looking back on things, how did I get to this position exactly? Do I have the big house or the fancy car, or maybe not, and why, and such and so. anyway, kind of funny, but it's kind of a theme that when I think about where I was at back in the 80s, I was about 12, 13 or so, and I was mostly stuck in video arcades at that time. So there's a picture of me from around 1981 or so, I guess. And I just want to talk about each of my experiences in the next few slides and how ultimately that ended up being relevant somehow. So I was addicted to video games. They mostly kept me off the streets and from getting into lots of trouble. So instead I was trapped in arcades, putting quarters into machines, and the quarters were hard to come by, so I had to get good at the game so that I could stretch the quarters out as long as possible. Then I heard some kid up the street said that he had a home computer and could make video games. I never heard a sentence that had make and video games together. And I thought, wow, that's mind-blowing. I didn't realize that could happen. Couldn't afford a computer, but I was able to start programming on a TI-99-4A like this one. I'm sitting up for display at Kmart, which is before Walmart there was Kmart. I don't know, but anyway. So for the sales guy, let me stand there all day writing programs, and so I was able to play around with BASIC there. Eventually I was able to work in the summers in around 84, so I'd buy a Commodore 64 and then hack all day and actually save my programs. That was very nice. And then I realized I had to jump into assembly language to make it fast enough, because BASIC was too slow on those old computers. So what was interesting is that it gave me some insight about video game development, even though it was very, very different back at that time. That's what got me excited about programming and eventually computer science and research and all kinds of things. I just went down a different path though. I thought about being a game developer, but it just wasn't, I found other more appealing things as I went along the way. And this concept of writing code in some kind of easy to use language and then having to jump into some sort of horrific language whenever you need to make it run faster. Turns out, as I've worked with people at Oculus, that's what the experienced software engineers are doing today in the game industry, and they're even in fact jumping right into assembly language using special SSE extensions and SIMD coding techniques and things. I'm like, wow, this is really interesting. It's mixing C++ instead of BASIC plus assembly code. So wow, it's really interesting. My perspective still was not that far off, even though this is what I was doing, goofing around when I was a teenager. So most of my career I've been a robotics professor, and as Laura mentioned, my education is from here. So I was in electrical engineering, got my PhD in '95, and I was a postdoc and lecturer at Stanford for a while, and then was professor at Iowa State, and then got the chance to come back here and join the computer science department as a professor at 01. What's interesting is that at a couple of points along the way, there were big industry entrepreneurial activities happening very, very close to me. And I remember thinking about them. One of them was, I was at Beckman right when NCSA was there, and Mark Andreessen and his group were making Mosaic, and I knew people. I mean, there was one person in our group, in our research group, who had an RA with NCSA and was working on exactly Mosaic, and I knew other people at NCSA working on other applications that you might not have heard of, like PolyView and other things like that, perhaps. And so, so I was very close to it, and I watched what they were doing, and I made a web page really quickly after the first sort of graphical web browser came out. This is great stuff. But I thought, but I don't want to change my career plans at this point. I was really happy continuing on with the PhD and learning deeper and deeper things and harder problems and the great challenges, and so it just didn't sound exciting. I was supposed to. And then all of a sudden I'm at Stanford in the mid to late 90s, and I saw Yahoo had grown really big, and Larry and Sergey were students there at the time, and we had mutual friends, and I was friends with a lot of the students in the PhD program there at the time and such, and so I also co-wrote a paper around the same time with Rajiv Motwani, who was also co-writing a paper with Larry and Sergey about this search thing they were developing. So that was kind of interesting. That became Google. So I felt like I was always very, very close. Very, very close to these exciting entrepreneurial stories. But each time I was like, yeah, that's exciting. Things are really heating up in Silicon Valley. But I'm going to go to Iowa to be a professor. So that's what exciting. I don't regret that at all. It was a great experience. I did a lot of research at that time that really shaped me and got a lot of visibility for me, so it was quite fun. Eventually there was a third time when it was Oculus, and I go, well, maybe I'll give it a chance this time. That's what I'll get to in a bit. When I think back in my education, there was a lot of electrical engineering kinds of things I was dragged through, computer engineering kinds of things that I didn't end up using all of it as a roboticist. Some of it, some of the times. But I was a head teaching assistant for a digital systems lab course here. And, a lot of students are grumbling about taking electromagnetics and semiconductor device theory when they were computer engineers and such. I actually didn't mind it. I was always trying to learn as many things as I could. But what I found was that while I was hanging out at Oculus, I got to meet real engineers, people who have been doing engineering for 10 or 20 years. And when they were in the electrical and computer engineering space, or even if they did things with MEM sensors and mechanical systems as well, I realized I knew a lot of the language to be able to talk to them, and I understood a lot of their issues. Some of it came from being a roboticist as well, just interacting with a lot of engineering people in that context, but also it was just, I understood where they were coming from, even though I didn't have all the professional engineering experience in those areas. I was amazed that I could just kind of jump in and converse with them and have effective conversations and brainstorm and such, and I thought that was very nice. So that was very useful to me to have that extra broad background. You never know when it might come into play. My research area for a long part of my career is in motion planning. Sometimes people call it the piano mover's problem. Imagine you have a geometric model of a building, like maybe this building, and then you have a geometric model of a piano, and you want to figure out how to move the piano through the building without hitting anything. Maybe you've argued about people how to turn a sofa while you're going up the steps and going around corners if you've moved before. So this is software that does this automatically. What's interesting about it is that it's very closely related to video games. And I developed an algorithm called rapidly exploring random trees, which actually does get used somewhere in the video game world. I didn't know about it until I went to the video game world with Oculus and talked to people and such. But most of the work we had to do, especially back in the 1990s, was in simulation because it was very complex to even acquire a robot. It was expensive or required a lot of extra lab work, and if you spend all your time on that, you don't get time to develop the algorithms and the software for motion planning. So I tended to do more on the algorithms and software side. So this gave me experience with virtual environments. Just writing code on silicon graphics machines and hacking in OpenGL and understanding the basic operations of computer graphics and simulation and collision detection ended up being part of my research, and it's very closely related to video games and virtual reality, but I was officially a roboticist. So it's just another place where I was close. I could hack some of these things up and I understood what was going on. The research I did in motion planning, most of it involves searching through a space of transformations. A lot of people who work in, maybe very often apply transformations, but they might have to think a lot about things like dynamical systems on the space of all transformations. And in that case, how do you parameterize these spaces? How do you deal with these spaces? There's geometry in them, there's topology in them, there's a lot of deep issues in there that are subtle, and if you don't get them right, your code will end up with a lot of strange bugs or kinematic singularities, gimbal lock kinds of things show up. There's all kinds of weird problems that happen if you don't know the subtleties of the mathematics behind these things. And so that's a background I already had being in motion planning, and I also had a lot of experience doing numerical implementations, actual coding where there's numerical problems and sampling problems in exploring these kind of spaces. So in order to do head tracking, it turned out that's very relevant kind of stuff, very relevant kind of math and algorithms that fit together in some way, but it doesn't look like virtual reality on the surface. Right? So it ended up being very relevant. So that's another way how I was close to these things, even though I hadn't worked in virtual reality before. Also, when I was starting off as an assistant professor, I wanted to make a good software foundation that my graduate students could use so that they didn't get caught in all the pitfalls I did. Whenever I wrote code as a grad student, I wrote a big sloppy mess that barely worked for the conference paper. And then, only I understood how to use it or build on it. And then by the time I finished my PhD, I couldn't build anything on top of it anymore. It was such a mess. So I wanted to start from scratch. I worked with there was a software engineering professor at Iowa State I became friends with, and he gave me a lot of advice on just C++ object-oriented design and how to set up a class and how to do things. And so I worked very carefully on that, wrote over probably 90% of the code in this library. It became an open source C++ library for doing motion planning and for visualizing the results. And it was all in C++. And I would say that had I not done this, I probably would have never been able to get into Oculus at all. Because you needed to have at least some minimum level of competency in C++ development and software engineering, more than what I would have in, say, a standard class project. And the company was so small. If you go into the beginnings of a startup company when there's only a handful of people, you can't just hire sidekicks to go and implement stuff for you. You've got to do it yourself. So you think you know what you're doing, go implement it, or else you don't. And that's it. So I think I was just barely passable to the software engineering team. Okay, they saw my code, they probably checked out the libraries once, and all right, seems like he knows what he's doing, he won't screw things up too much. So it was just enough. So having put that time and effort into it, I didn't think I was preparing for some future of entrepreneurship, for sure. But if I hadn't done that, and at least designed some really big system like this, and then worked with students to enhance it and improve it and such, I don't think I would have been able to jump in and start writing Oculus code. So that's something. I wrote a book on planning around 2004, and I made it available on the internet for free all the time. I crowdsourced the feedback and development of it. I got a lot of comments on the book and a lot of corrections from people. That was very, very nice. And I got Cambridge University Press to publish it for free, even though I could keep it on the internet. Sorry, not publish it for free. They published it as a regular book, but I got to keep it for free on the internet. And so a lot of my colleagues and friends were saying, well, you never make any money that way if you just give it away for free. Well, you know, it depends on what kind of path and how long the path is, because Jack McCauley, the guy who made Guitar Hero, he's an electrical engineer and one of the Oculus founders, contacted me because he was Google searching for things like Euler angles and quaternions and found pieces of my free book online. And that's how I got into the company. So, you know, you never know what's going to happen. So just put stuff out there. It's a lot like people, you know, like maybe you have a nice app you're making in a startup company. You make it free and available to everybody until they get hooked on it, right? And the word spreads. And then later you can put in ads or other annoying things, right, to monetize it. So maybe that's what I did, perhaps. I don't know. I mean, I make this free book, but eventually it connects me to all kinds of people and all kinds of opportunities. So it's been very exciting. So the book was also a helpful part of getting into this. After I wrote that book, I worked on filtering and information spaces, which is something I was very interested in, which is in robotics. Where does the information come from? You don't usually have an exact geometric model that the robot just gets automatically. It has sensors. And I wanted to understand, for a given task, how much information you minimally need to solve that. Like, for example, if your goal is to vacuum the floors here, what information do you need? Do you need an exact map of the building? Or do you need to know exactly where the robot is with X, Y coordinates at all times or not? Do you need to know which way the robot's facing at all times or not? Very basic kinds of questions I found interesting. So I did about a decade of research on that, wrote a small book on this. The whole philosophy of minimalism, starting with the task and figuring out minimally what do you need. Turns out after talking to people who do product engineering and people interested in startup, making a product that the masses can consume, they're also interested in minimalism in the same way, because nobody wants a bunch of overcomplicated stuff in their system that's very hard to analyze, very costly, drains lots of power, and so forth. So like, wow, the minimalism is great. So this Oculus Rift device was very minimalist in a lot of ways. I started working on a larger book on sabbatical in Finland. They usually like to get away on sabbatical, so I went right about there, up near the Arctic Circle, and started working on a book about sensing and filtering, a large book of that. I was going to give that away. Everything was going to be great. But then Palmer Luckey disrupted my life. So it's called Disruptive Technology. So my plan got disrupted in September of 2012, so the book's still on hold. And I don't know when I'll get to that, because now there's a lot more exciting things to come, I guess. Why did I even jump into VR? I remember VR. It was very exciting back in the 80s, 90s. You know, here at the University of Illinois, again, at the Beckman Institute, while I was a grad student, the first one was done, of course, at the University of Illinois, Chicago, but at the Beckman Institute in the early to mid-90s, a cave system started showing up there, and I got to try that out, and thought that stuff was great. Too bad it's so darn expensive and not very portable and comfortable for a little while, but you know, I could see that, yeah, it could have a future sometime, but I wasn't ready to jump into it at that time as a research student. Things got so crazy. If you want to see how excessive the hype was, look for the movie Lawnmower Man. Just outrageous, over-the-top craziness for it. The official kind of death and burial of virtual reality in the business world, and this is in terms of mainstream consumer product business world, not in terms of niches like military, medical, things like that, but is Nintendo Virtual Boy. So this was a product here where it's like a pair of glasses, you put it up on the table, you put your face in front of it, it doesn't track your head, and it had monochrome graphics that were red lines against a black background. So you can play like some kind of crummy Mario Tennis or something, and it looks 3D while giving you a headache after a while. And so somewhere there's probably a landfill, you know, full of these things. So that was a disaster, and everybody in industry then learned, don't touch virtual reality with a 10-foot pole. Keep away from that stuff. But when a new generation of people come, like Palmer Luckey, right, a lot of others come, they don't have that history or baggage that goes with it, or the fear that goes with that, and so they try something new. So what was happening was that the component technology just wasn't ready yet, back when the hype was being built up. I think the components couldn't get there fast enough. The big things in the 90s ended up being things like the web browser, the search engine, right? The technology was there for that, but it wasn't there for all this extra hardware and components, all the extra engineering that had to come together and work seamlessly and reliably and cheaply and portably. All those kind of things weren't there. And as a roboticist, I've seen this happen again and again. In robotics, very often, we find some device borrowed from somewhere. There was a thing called a sick laser, which made our robots much, much better at measuring depth in the 90s. All of a sudden, everybody's research got a lot better. You know? Now people put connects on everything, you know, put depth sensors on everything. All of a sudden, people can do great 3D modeling and map building a lot better. So a lot of the credit goes to these devices that show up from the consumer product world. So I had seen that kind of idea before, so I had enough insight at least to think, yeah, these guys probably have the right story here, that the component technology wasn't right yet, and now we can make it out of the simple pieces that we have thanks to the smartphone industry. So it turns out the screens used in the smartphone industry and the MEMS sensors inside of smartphones that detect tilt and various, you know, those little apps you can play with a ball rolling, you know, all these kind of nice things. The technology is there. The graphics processing units in there have advanced quite a bit, and the GPUs in our PCs are amazingly powerful compared to the old days. So you can get away with a lot of things that you couldn't do before. So Palmer Luckey's insight was, and a few others at the time as well, to put magnifying lenses in front of a screen and then use the MEMS sensors or some family of sensors of MEMS that are similar to do head tracking. And you can do that all for pretty cheap. So that was the idea. I also jumped in because I had a personal interest. So most people were interested in first-person shooter games. Video games are still a massive market, and all the 3D models are there, and people want to just jump right into those models and feel like they're there. My personal interest was to try to bring people together. So here's a motivational story that I have a very personal interest in. Also, while I was a grad student in the 90s here, I went away and took a trip to Poland after the Soviet Union collapsed. And I was able to get my grandma, who was 73 at the time, with her sister, and they were separated after World War II. They were displaced in Germany as agricultural workers, and they couldn't find each other in the chaos after the war. So my grandma got to go to St. Louis. They both had an aunt there, but they couldn't find her sister. So they only got to see each other a couple of times in 60 years. And this was the last time I got my grandma there, and she lived another 20 years after that. But I never could. I could get them Skyping or talking by phone or doing things. But I thought, wouldn't it be great for people with limited mobility, whether elderly or they have other physical limitations, to be able to feel present somewhere else? Right? You could be at a family member's, you could be at a grandchildren's birthday party or something on the other side of the world. Wouldn't that be nice? So I thought the opportunity for this technology to give you a feeling of a telepresence, I found very exciting. So that was a personal motivator for me. So we started working on it. We started improving the technology. There's a lot of, when we were at Oculus in the early days, a lot of people with big black bricks strapped to their faces going like this. It's a very, very weird place to work. We had a lot of fun. My wife Anna and I were in an apartment in Finland. You can see it kind of looks like IKEA there in the background or something. And we had a robot that the company got us with. This is the sensor strapped onto the end. We were doing sensor calibration and characterization of noise studies, and then trying to improve and characterize the performance of our systems without always having to move our heads around. We can move the robot systematically and characterize that. So one of the things I suggested they buy and try to study these systematically. They still use the robot there for doing these kinds of things. So we were working on that at the time, and we sold all these headsets. The software was available. People started making all kinds of things. My favorite thing to do at Oculus was to take a break and see what people were doing with it. Right? So one of the first things I found was this, which is someone strapped it to their 90-year-old grandma, and she went in this virtual Tuscany world that we made. For me, this was like a tiny prison. I spent so much time in this virtual world trying to fix all the bugs, trying to figure out what's wrong, trying to improve it. I got tired of it. It was just a tiny courtyard with a stone fence around it, every little feature in there, just horrible. But she was just tickled with joy. I can't believe I'm here. It's so real. It's amazing. So it has millions of views on YouTube. I thought that was great. So that made me feel perfect. Like, it just takes no explanation, right, as far as why this is an interesting device. She didn't have any training. They just strapped it on her. She didn't even have to hold it with her hands, but they just let her do whatever. She was having fun, having a good time. What else are people doing? Well, people started building big virtual spaces that feel like a comfortable place to live in or to run around in. This especially happened from people in East Asia. Maybe it's like Tokyo or Seoul or Shanghai, and they're used to having small apartments. So imagine coming home to relax, you put on the headset, and all of a sudden you have this big comfortable place with fountains going, and you can have your friends over maybe, and then they get jealous and have to build their big virtual palace. And it doesn't cost anything, it's just nerdy fun, right? So a lot of that kind of stuff started happening. Of course there's a market here for architecture and virtual prototyping and visualization of all kinds of things, but But there's also just, a lot of it's just young people having fun. One of the first apps that came about was virtual reality cinema. A young man in Korea made this in his early 20s, made it in a few weeks, where there's a virtual movie theater with a bunch of chairs, and you can sit anywhere you want in the virtual movie theater, and it will stream movies off of your hard drive onto the screen in the virtual movie theater in 2D or 3D, and you look back and the projector's flickering, and the acoustics are adjusted for the room. My first thought was, that's kind of lame. Why would anyone want to do that? But that was the only one that kept my kids captivated for longer than 10 minutes. So they just sat there, okay, How to Train Your Dragon. I'm at the theater watching it. And it tracks your head while you're watching it. So you don't perceive the screen as moving around. It's tracking your head so that it looks like the screen's just there, some giant screen in front of you. It's very relaxing. And then, of course, people are starting to make apps that do more than just that. You can enhance the movie, right? Like I was thinking, I remember the little movie Twister with, we like tornadoes around here, right? So imagine the little movie Twister with tornadoes, coming along. Well, you can rip the movie theater apart with a tornado right when you're watching the movie, right? Or you could have a zombie movie with zombies showing up in the theater. So you can annotate existing movies and give some kind of crazy experience. You can also make social experiences. People are already doing that, where you can have movie night and you just get together with your friends in the movie theater and do physically implausible things without getting thrown out of the theater. So, this is one of the interesting early things. Somebody connected to Google Street View, where, is this virtual reality or augmented reality? I don't know. The terms I get kind of tired of. I don't really know what to do with them. But the Google Street View car went around taking panoramic pictures, right? And they're mostly just non-panoramic pictures that are glued together in some kind of crummy way, and you can sometimes see the seams between them when you scroll around with your mouse and zoom and look. Well, someone just connected the Google Street View server to the Oculus Rift, and they actually did that before our software even came out, and before our headset even came out. So we got to try it like a week before we even released all of our stuff. There were people so motivated, so excited, they somehow figured out how to make it work before we even gave them everything. And so it worked. I guess they must have had some of the software, now that I think about it. Maybe they had some version of the software before the hardware came out. But they even said in one of the forums, I'm not sure if this will work yet, I don't have an Oculus Rift to try it. We tried it and it was amazing. And right away we took turns visiting each other's childhood homes. Saying, here's where I used to live, and we put it on and you can look at it. It really feels like you're there. And nobody gave any concern to the interface very much on this, except your head becomes the controller for deciding where to look. And you feel like you're there in a bright, beautiful panorama. And there's no stereo. It's the same image presented to both eyes, but it's very far away, so it was very comfortable. That really surprised us. Simple things people do that are very comfortable, and they leverage existing content. That was another interesting idea. So a lot of people wanted to leverage existing content in 3D first-person shooter games, so a lot of that went on. Valve made one of the first integrations of Team Fortress 2, but we found out very quickly that it's a super intense experience, and may make some people feel a little queasy or uncomfortable, because there's a lot of motions going on where you're seeing optical flow. So when I move like this in the audience, I see optical flow, and I get the visual sensation of that, so my brain knows that I'm moving, but my vestibular system is also measuring those accelerations. And so there's a nice match. If I'm sitting in a chair and I see the optical flow, my vestibular system doesn't get that information. It just says you're flat, you're sitting. The Rift knows that you're sitting also. It has sensors that do almost the same thing as your vestibular organs. But your eyes have been fooled into thinking that you're moving. You ever sit in traffic and there's a big truck next to you and then the truck starts moving and you feel like you're going backwards? And it's a little bit nauseating and disorienting. So imagine making an experience where you're just doing it to someone over and over and over again for no good reason. So that's the kind of stuff that happens. So some of the things we can leverage are helpful, and some of them are harmful from what exists out there already. So leveraging movies that already exist, very easy, right? Google Street View, easy, very comfortable for everyone. This stuff, yeah, sounds really cool, but it's uncomfortable. So how do you make a new generation of video games that are comfortable? We had a virtual reality game jam where this was one of my favorite entries. This isn't a first-person shooter. This is, you have a big virtual elephant trunk, and it feels like it's extending from your face, and you just swing your head around and your trunk flops around. And the only purpose of this game, that's not hacked up in a few weeks, is to knock stuff down. What could be more fun than knocking stuff down with a giant trunk? And all you're doing is moving along a track at a speed you cannot control, and you just use your trunk and knock things down. I love that. That was really fun. And so that's the kind of innovation that, put it out into the wild and let people try to hack whatever they want. It did a lot of fun things. And of course, there's always people making virtual roller coaster rides, wanting all kinds of thrill-seeking experiences. And you know, that's not going to be comfortable for a lot of people because of this problem of observing the optical flow. A real roller coaster might not be comfortable either. This one's another experience that's different though, because you're sitting in one place and then you're getting the sensation of moving while you're just sitting there on the couch doing nothing. Right? So it's very, one of my favorites, which no one's ever taken me up on, is I want to go on a real roller coaster and then in virtual reality be sitting on the couch doing nothing. I think that would be comfortable. I haven't seen anyone do that one yet. It just gets more and more disturbing from there. I had a lot of weird things start happening. It turns out art students are the best. They come up with all kinds of crazy things to do. Wouldn't it be great to have a guillotine simulator, right? and so you look up and you see the blade coming down. There's a great video you can find on YouTube. And so you can see the blade coming down to cut your head off, basically. And their friends, of course, when they start getting kind of punchy and goofing around, they whack their friend in the neck because they can't see right when the blade's supposed to hit. And it even shows the perspective to your eyes as your head's rolling in the last few moments of life. So if you ever wondered, here's a chance. Really bad, I know. I can put, it gets more and more perverse and strange, but you can find your own stuff. Socializing in virtual spaces. So I was always interested in Second Life. It got up to a certain level of interest and then plateaued about 10 years or so ago. The makers of Second Life, Philip Rosedale and Corey and Drake and others were very excited about virtual reality, but they knew that it wasn't ready yet so for a full immersive experience, so they did the best they could on screens. And they made entire societies where people interact and mingle and do all kinds of weird stuff, including make money, right? About virtual currencies inside of these spaces and such. Now it's not surprising with Bitcoin and other things, but the Linden bucks that were around there, it was interesting. There was an economy, a real economy, that you could exchange for dollars at that time. There's an open source movement. There's OpenSim, which is an open source version of a Second Life-like simulator, so a bunch of people can connect together through there. And I gave a keynote address at the OpenSim conference about 2 or 3 months ago. And I'm looking out, and there's an audience of, you know, a couple hundred weird-looking avatars out there. Everyone looks, you know, really fit it's strange, you know. I have this memory that I was at a real conference giving a keynote, but I was just sitting in my house, you know, wearing whatever and just talking. And there were a lot of good questions. There was a real audio part, but the visual was all just avatars. And I just did it on a screen, on a big screen. They do have it connected to the Oculus Rift already, and they can do that as well, but we didn't want to make any more technical complications that were necessary. But I thought it was really fascinating. So all kinds of social interaction stuff is happening. I'm going to finish up here and allow some questions. I got a good 15 minutes worth of questions or so. What did I mainly work on? Head tracking. So basically that involves gathering data from the sensors and fusing it all together to figure out the orientation of the head. Then I later worked on orientation plus position so that you could go back and forth like this and you get the proper view. A lot of the tricks were trying to get it to be very low latency using some special predictive tracking methods. I combined some ideas or observances that came about from perceptual psychology and tried to mix that to make perceptually tuned filtering methods to try to really get it to work as well as possible. Also, there's a lot of people in the game industry are stuck using the off-pitch roll representations because they're very easy to code, and it turns out you end up with singularities in the transformation that are like gimbal lock if you end up using those. I don't know if you ever had any experience with these kind of things. If some of you have an aerospace background, you might know this from graphics. So, but if you look straight up or straight down, if you're using Euler angles in the kind of the standard way, the world might start spinning and you end up with numerical instabilities and all kinds of problems. So, quaternions can fix that, and other representations can fix that. But there's certain bad things that happen, like in some game companies, they may make a declaration that nobody's going to use quaternions anywhere in the company because they're too complicated. And then they don't do it, you know. But I'm like, so we had to constantly battle with those kind of misconceptions about what the math is good for, what you should use or shouldn't use. And in a standard video game, you can only pitch the character's head up or down a fixed amount. So, right, in the kind of games you have on an Xbox controller. So you never could look straight up or straight down anyway, so they thought they were safe. But then when you take the same game and same code and you put it together with a virtual reality headset, you can look straight up and then it makes a mess. So there's all kinds of weird things like that going on. So I quickly got into perceptual psychology after realizing that it's a lot more than just tracking graphics and such. So there are all sorts of issues coming together. I pushed and was able to successfully hire a couple of perceptual psychologists, and so I led a small team. One of them is named Richard Yao, who's a PhD from here. He was a student of Dan Simon's. And so, so they did great things. We spearheaded the writing a best practices guide that was based on science to give advice to developers. We also got heavily into health and safety. And so we wanted to minimize the adverse effects of disbelief, well, you don't even believe it works, fatigue, and the worst, simulator sickness, try to make comfortable experiences, and to educate developers on that, and even people inside of the company. We constantly had to educate and re-educate people on that. And it's very complex because people adapt. And of course, the hardcore gamers are so used to staring at big screens with a bunch of stuff flowing by that they're the least susceptible to discomfort. So they've trained themselves. And so they often make stuff that's really uncomfortable for everybody else. So how do you get them out of it? And so it varies across people by age and gender and all sorts of things as well. So it's very complex. Or for reasons nobody could imagine. There's so much variation. So there's a lot of design and experiment problems here. We eventually made a second development kit that got released last summer. We have 25 of them that were donated by Oculus, and that's over in an instructional lab for VR. I'm teaching a big VR course. We're using that. We added infrared LEDs to the surface, so instead of using just these smartphone kind of sensors, we also have a camera, unfortunately, but it provides very good position and orientation information. And we put all that stuff together. And it's interesting, it was roboticists who were doing this stuff, so they're not virtual reality people. My wife and I, and Max Ketchup was my graduate student from here, who's now a roboticist who we recruited at Oculus as well. So we all work together on these things, which I found very neat. So again, I guess the lesson of that is you might not be aware sometimes that your background that you have may be very close to some field that most people think is completely different. Right? But it may be very simple. So if you know the fundamentals very well, you should know how those things map over to the other problem. Right? I found that in industry people were much more obsessed with, okay, the only person who can solve this problem is someone who's done exactly that problem before. You know, that's very reliable. You get them in there, they've done that before, they'll be able to do this. But there were a lot of problems when I felt like I was not too far away. I just needed to study for a week or two and then I could jump in and do it. Just give me a week or two, please. You know, maybe you have a week or two or maybe you don't. It depends on what kind of business you're in and where you're at and what your deadlines are. But there were a lot of problems with if you just have the fundamentals, you're very close. And if you have to do something very innovative, especially in a startup company like this, there's not a lot of VR head tracking experts around making products who are willing to jump into a startup and make products in these days. Well, there are now, but there wasn't in 2012. Then you know, they'll have to put up with the trying to retrain some people or get them to adapt what they know into this context. So there's all kinds of new hardware demands in industry now. So a lot of exciting things going on. People need, you know, once you put magnifying lenses in front of screens, you notice there's pixels there, so people want higher resolution. They want faster frame rates. It's all part of comfort again. Just like frame rates had to go up really high on CRTs a long time ago when they started making really big ones. There's ergonomic standards and things. The graphics need to improve and get faster to make things more portable. All sorts of stuff going on there. Software issues as well. How to design good user interfaces, better tracking, perception of graphics. So how good do the graphics have to be? There's a lot of shortcuts and tricks you can do in computer graphics, but that's for graphics on a screen, not stereo vision presented to your eyes. So there's a lot of different possibilities there. Even just what kind of middleware needs to be written. Right now, a lot of people are just using game engines. But game engines are middleware for making games, not for making virtual reality. So what should the new generation of middleware engines look like? Who's going to lead that? Universities with some open source projects, companies by might and force, some combination, some coalition, who knows, right? I bet the best one won't necessarily win, right? It'll be some random strange thing, and a few years later we'll look back and say, oh, I guess the big VR engines are this and this. You know, the interesting story. So there's a lot of great things, and there's a lot of opportunities for collaborations across disciplines. Myself, I'm very interested in human factors and perceptual psychology right now, and reaching into applications of virtual reality all the way into art and humanities. A lot of interesting applications here. And you know, there's more senses to stimulate. So there's an audio component. I talked a little, mainly showed visual things, but there's an audio component. Once you track your head, you also know which way your ears are pointed, so you can simulate localized audio sources. If you know about head-related transfer functions and things like that, you can, you know, all these things start to come into play and become valuable. Haptics and touch, very hard to get that working, especially in a low-cost, portable framework, but people would like touch feedback. Taste and smell, I'm not really sure what to do about that, but might as well list all the senses here. And vestibular, I don't recommend stimulating your own vestibular system. It can be dangerous, but maybe there's things you can do to help mitigate some of these other problems I was talking about. And there's all kinds of human-centered research all around, I think, especially in the form of, this is human-computer interaction or human technology interaction at the lowest levels. You're replacing, you're presenting with these displays alternative stimulation to your eyes, to your ears, and so forth. And so a lot of things, the human is half the system at least, and we didn't engineer the humans. There are people who sit around trying to reverse engineer what's going on, and to be able to do telepresence kinds of applications where I have an omnidirectional camera put somewhere interesting with a robot interface to it so I can move it around, but I just sit here and I get to look all around, and maybe I'm walking around in a nice plaza somewhere on the other side of the world, right? So that would be very nice. So I'll stop here and take questions. While I'm taking questions, I want to show a background video. It's my favorite experience. It'll just kind of play. This was called Birdly. It's a virtual flying experience done by an art professor in Munich. And you can flap your wings, and there's a motion platform, and it's about the closest thing to what flying feels like in your dreams. You can do this in the real world. There's a fan blowing in the face there to based on how fast you're going. I got to fly around through virtual San Francisco. So anyway, now I'll take questions like I promised. Yes.
You had mentioned all the challenges. Power consumption. How many challenges with getting the proper power sources and your power consumption?
I think every once in a while we had problems because of USB 2.0 limitations, and then eventually it might have gone to USB 3.0, and it may have more. I remember the computer engineering folks were worried about that a lot. And so do we have to plug another device into the wall or not? It's already cabled. And the Oculus DK2 is tethered to the PC by an HDMI cable. So it's a lot of information to get. It's hard to do that wirelessly at the rates that we want and the density that we want if you're doing the main computing on a PC. Once you're entirely inside of a smartphone, then you can only do, let's say, simpler kinds of experiences, but you're using hardware that's already more or less been designed to work on very low power. So, but it does hamper everything. If you want to do the bleeding edge graphics, then it draws a lot of power, hence you need a base station. And then to get all the information onto the headset, you need wires. So far, maybe you need wires, maybe that's kind of strong, but you certainly cut down on reliability and you drive up cost and there's a lot of issues. It's a good question.
So I know you talked a little bit about human fatigue and so forth. I was wondering how bad does the when you have stereo cues and accommodation cues that are in conflict with each other, a lot of people get tired by that. I've had some experience with devices where those are in conflict, and I'm wondering, how long do people that use this sort of device without, essentially feeling muscle fatigue, getting tired out?
I think that's a very good question. That's certainly a well-known difficulty with 3D movies and the way that we view them, and with this technology as well. Just to kind of reiterate this, is that when your eyes converge, you very often are simultaneously refocusing them, unless you're over 50. It's starting to break down for me. I can't do it too much anymore. But so these are nicely coupled. However, in this virtual reality experience, the world is always in focus, no matter how close it is. So you're bringing your eyes together, but it's still in focus. And so your brain gets confused and says, oh, I don't have to focus, or it may accidentally focus and make it blurry when it was already clear. So it's decoupling those two muscles, let's say, those two sets of muscles. And whether or not, I don't have the general answers on it. People have studied that for a long time, I think. There are scientific studies on that, and I can't comment on Oculus internals and what they're doing with that. But I think there's also a good question is adaptation, or how do people, after doing it enough, adapt to the experience? I think generally a wise thing to do is to not put too many things very close in the near field. That's what people did, I think, over the last few years in movies at the theater, 3D movies. They just kept stuff further away. I'm actually personally not a big fan of stereo. I love the monoscopic views of Google Street View. There's a lot of interesting things people can do in these kinds of applications. If it's an application where you really have to have things very, very close in order to make it work, well, personally, I would steer away from that for the moment until one can figure out maybe some technological solutions such as light field displays or things like that that might allow the vergence and accommodation to be like it is in the real world.
Okay.
Yep.
What was the hardest part about balancing like engineering, startup, results-driven mentality with the research, making sure you get things right and you pushing the envelope there?
Yeah.
Or were they not in conflict?
It's kind of interesting. And I guess they started off not too much in conflict because there were so few people. And it was crazy. Some of the problems I had to solve, I normally would like to have like 4 months to solve them, and I had to do it in a week or two. And that was pretty stressful. I'm not as, you know, when I was in grad school, I could work crazy hours and do all kinds of stuff, but it was just, I was feeling the hurt from it. You know, I can't pull all night or something anymore and stuff like that. So sometimes that was difficult. As the company got larger, it became a bigger challenge because yeah, there got to be a lot more focus on shorter deadlines and making systematic sort of progress. And the number of people who could get their hands in on the code got to be larger. And people would come in and start interfering with stuff and breaking things. And then there's no like professional plumber to go in and like fix everything, right? And so trying to balance between, you know, I was responsible for head tracking stuff, and I wanted to move on and do some other parts, but it got almost impossible to do that at some point because they needed a professional like code maintainer just to keep over those parts, to keep them from getting screwed up as they kept integrating more and more pieces of software and things like that. And so that got to be probably one of the biggest challenges as I got for long. In the very beginning times, there was just a handful of us. It felt almost like grad school to me. It was it was very kind of pure and nice, and I knew we had to get things done on certain deadlines and such, but you know, give me 2 or 3 weeks and I'll make the best thing I can, and it wasn't like the things I had to do were massive in the amounts of code or the amount of infrastructure. I tried to go for things that were very, very simple, very clean, and we could build on top of. Even if they weren't perfect, I wanted to at least be simple and understandable, and that was reasonable. And that was an insight I had as a researcher too. I always try to do things that are simple and understandable and clean. But eventually, things just explode. There's so many people contributing to the code, and it's hard to figure out how the whole thing, you know, fits together and stuff. And then there's big arguments about how it should all be re-architected and everything. It's like, oh, no, that's what gets a lot tougher. Yes.
It sounds like you find the binocular experience very compelling. Do you find that the head movements and the dynamics with the headset are most of the experience rather than the raw 3D input to your eyes?
Yes, I think when I saw the Google Street View, that was amazing to me. That the wide field of view and very accurate head tracking with low latency was already something incredible. You know, I just wanted to have live video cameras, panoramic, set up around the world, and with audio, and I just wanted to hang out. And I could do that all the time for leisure. It'd be wonderful. You know? So that just felt amazing to me. So that was such a big part. So many people are worried about virtual worlds, and then you got to get all the anti-aliasing and texture mapping, all this stuff, so many shaders and polygons flying around everywhere, all this extra stuff. I'm like, wow, this is already something really beautiful and amazing and very comfortable. And some businesses can be built around that right away. You know, that was quite nice. So some of these things that people get obsessed with come with a cost. The stereo part may be causing more discomfort, maybe harder to get right, and it might not be necessary in a lot of applications. Of course, we can always design something. If I say, okay, just ignore stereo and you're fine, then somebody says, oh no, because then the product wouldn't work for this or this, and that's fine. You can find exceptions. But you could also find entire markets where or uses where a lot of interesting things can be done without stereo. So I like to think of comfort first and simplicity and reliability and things like that before getting crazy about making sure it covers all the features kind of has it all working.
We'll do 2 last questions. There are 2 in the back.
Okay. So I have one. Are there any plans to integrate body limb positioning via like an Xbox Kinect or wearable sensors, so that way when you move, your avatar will move its arms or legs or something like that?
I can't really comment on Oculus plans, but in general, everyone's interested in tracking more than just the head. One of the first things you notice, you look down and you're like, I'm not there. Wait, I'm here, but I'm not here. You know, it's a weird ghost-like experience. Even just a very simple rendering of a torso helps a lot with your perception of scale and your feeling of presence. You can, of course, wear a full body marker suit and go running around in a motion capture environment and get your whole body there. You really got to think, I really like to think, what's the application? What's really the problem people are trying to solve? Because what I find more interesting is to design a very simple interface where maybe through very small motions you get your arms moving around in virtual world in a way that your brain believes, but in the physical world they're not moving very much. Like, do we necessarily need to have, for most of our problems, a perfect one-to-one geometric correspondence between the virtual world and the physical world? For head motions, probably, for comfort. But for these other body parts, I don't think so. Just like when I take the mouse and I move it a little bit, it feels a lot like my fingers moving around on the screen, but it's rotated 90 degrees, and tiny motions here correspond to big motions here. That's a motor program that your brain has learned, and it's very comfortable. It's a lot more comfortable than doing this all day. You want to try this for like hours at a time, it's pretty bad, right? So that's how I think it's called gorilla arms by HCI researchers. This idea that you may do something very exhausting by trying to make a perfect correspondence between the physical world and the virtual world. So I personally don't like that direction too much, but tons of people are going to jump into that, especially because there's Kinects and depth sensors and all kinds of stuff for people to play with. So it makes a cool demo, but I don't know how that is for long-term, for like a long-term sustainable interface.
This is somewhat unrelated, but I was curious if you can comment on how something like this can be the cochlear implant equivalent to a blind person.
That's interesting. I don't know anything about blindness, so I assume there's all different kinds of losses that happen, right? There are retinal displays, so if the blindness is due to the optical system part, then I assume if you have some way to beam the right coherent light onto the collimated light onto project the appropriate images directly onto the retina, then you should be good, right? If you can figure out a way to do that, again, without causing further damage to the eye or the person in general. If you could go further and I guess if you can get the right information to the optic nerve, then just bypass everything else afterwards that's broken, then fine, right? I don't know how to do that exactly. I guess there's a lot of vision scientists and neuroscientists who study all these parts from all the way starting with the cornea, going all the way back to the visual cortex, right? And so wherever you can kind of cut off the front end and apply the right stimulus, it should work. But I'm no expert on those things, but I find it fascinating.
All right, well, thank you again, Steve, for